Okay, so when we're doing factoring completely, basically what that means is we're looking at a factoring question for the first time, and the first thing you're going to do is a GCF method. You always want to start with GCF method, but sometimes it doesn't end there. Then you've got to factor the leftovers. If there is no GCF and it's a difference of two perfect squares, you might have to factor the leftovers as well. So, but we always want to try GCF method first, but you always have to make sure that you look at whatever's left over and see if it can be factored again. And in pre-calc, a lot of times there are. So we want to make sure that you get all the parts and pieces. Here's your first example. This one should go fast. 5x squared minus 125. So right away, I noticed that there's two terms, and it looks to me like it's got to be a GCF because I can't take the square root of 125 nor 5. So what I'm going to do is I'm going to take the GCF of 5 out. So I'm going to start here, make my parenthesis, and I'm going to divide everything through by 5. So 5x squared divided by 5 is just x squared, minus sign, and 125 divided by 5 is 25. So this is the first step, which is GCF. But if you notice inside the parentheses, what's hiding there? What is that thing in the parentheses? Oh, this is a difference of two perfect squares. So you have to factor this again using our difference of two perfect squares method. So what happens to this outside 5? It comes down. You're going to have two sets of parentheses. Remember that we divide x squared into x and x, and we take the square root of 25, which is 5. And for a negative to happen, we need opposite signs, a positive and a negative. And this is your final answer. This is factored completely. Second example, 2x to the fourth minus 32. Again, looks like it could be a difference of two perfect squares, except 2 is not a perfect square, neither is 32. So the first thing we're going to do is GCF. You notice that 2 goes into both things, so we're going to GCF that too. When we do that, we're going to have one set of parentheses, and inside it, we're going to put the leftovers after we divide. So 2x to the fourth divided by 2 is x to the fourth, minus sign, 32 divided by 2 is 16. So if you notice inside the parentheses, we have a minus sign, a perfect square, and an even number. So you have to factor this. Just like the last one, this is a difference of two perfect squares. So our 2 is going to come down. We're going to have two sets of parentheses. We're going to split up that x to the fourth into x squared and x squared. We're going to take the square root of 16, which is 4 times 4. And we know that for a subtraction, we have to have opposite signs, so a plus and a minus. So we look, and guess what you should see? Another one. We have to factor this one. Here's another difference of two perfect squares. So we're going to bring the 2 down. We're going to bring the sum down. You cannot factor a sum of squares. That is not a thing. You're going to bring down that x squared plus 4 and leave it alone. Now, because this has a minus sign, yes, indeedy, we are going to break this into two more parentheses. X squared gets broken up into x times x. 4 square root is 2. And we have a plus and a minus. Are we done? Well, this is a sum, so we can't. This is a sum, so we can't. And can I take the square root of 2? Nope. So I am done. This is the answer. Factoring that entire little guy up there turns into this huge mess down here. And believe it or not, this factoring method is going to be most helpful when we're solving for all of the values of x and graphing them. And that is coming in our polynomial unit. Last example. Looks simple enough, 81 minus x to the fourth. But this one doesn't have a GCF. I don't see a GCF. And sometimes that happens. Sometimes there isn't a GCF. And in which case, you got to go to plan B. Plan B is, all right, it's got two terms. Is it a difference of two perfect squares? Can I take the square root of 81? Yes. Is my exponent on my variable even? Yes. Is there a minus sign? Yes. All right, so we're going to start this one with a difference of two perfect squares. The square root of 81 is 9. Now notice, 81 is first, so 9 has to go first. X to the fourth breaks up into x squared and x squared. And this minus sign becomes a plus and a minus. Now we scan. This plus is done. You cannot factor a sum. See the one with the minus? Can I take the square root of 9? Yes, I can. Is my exponent even? Yes, it is. And do I have a minus sign? Yes, I do. So that means that right here, this one, I can factor this part again. I cannot factor the positive or the one with the plus sign. It just comes down. You cannot factor this. It's got a plus sign. It has to have a minus sign for you to break it up. So we have two sets of parentheses. What is the square root of 9? 3 and 3. And x squared gets broken up into x times x, two equal parts. And the minus sign means we have a plus and we have a minus. And I'm looking, I'm scanning. See this minus sign? Can I take the square root of 3 and get a whole number? Nope. So that means that this is the final answer. And it needs to be in this order.